Now you got boiler. Okay, so boiler will have one combustion chamber, combustion chamber. Okay, now you are giving fuel plus oxygen, and you have maybe your water pipe will be there, water will be getting heated up and is going out, okay, steam out, maybe water tube, and your flue gas will be going out. So what is happening, your flue gas will have lots of heat. So what you can do, you can use that heat. Okay, for that scientists thought, let's use one economizer. Economizer means like boiler you have, okay, boiler sending hot steam to turbine, then condenser, then pump, then boiler. So pump, when sending fluid to boiler, so the temperature will be lower normally. So they thought, let's use this exhaust gas or flue gas or stack gas, flue gas or stack gas, use heat from flue gas or stack gas and increase the feed water temperature. Okay, the waste heat from flue gas used to heat the feed water. Okay, then you are using some of the waste heat to increase water temperature. So your boiler performance will be increasing. This is called auxiliary heat exchanger. So economizer is a heat exchanger. Okay, another is air preheater. So you are taking lots of air. Air contains very lower amount of oxygen and majority will be nitrogen. Now whenever air is delivered to your combustion chamber, the air temperature is very low and combustion chamber temperature is high. That means you are increasing air temperature first, then you are you are burning the fuel. Now can you increase the air temperature so that your combustion efficiency will be increasing? So again you use flue gas and increase the air temperature and increase system efficiency. So increase air temperature before it enters the furnace, generally placed after the economizer. Okay, so economizer and air preheater both are helping to increase boiler efficiency, and it is taking heat from your flue gas or exhaust gas that will not be used normally. Okay, boiler injector. Injector I already discussed, usually employed where space is not available to implement feed pump. So very compact application. Your injector delivers water to steam boiler, can take the form and eductor-jet pump. So eductor-jet pump or jet pump, whatever I explained already, that nozzle type thing. So that same thing actually. So they have different name. Water jet pump, water eductor, aspirator. There's a different name is there. Using that one, feed water can be injected. And here two terms will be coming, boiler makeup water, sometime the term will be coming. So makeup water actually not feed water. Boiler makeup water is introduced into the system to compensate water loss during operation. So whole system is running, boiler, turbine, condenser, pump. If there is a leakage, so there will be some water shortage, and boiler will have fixed amount of water. Okay, if you have less amount of water, then the whole system will not develop required pressure. Okay, so you have to maintain that much of water. So for that, what you do, you give some makeup water every time. Okay, and that makeup water will be compensating your loss. And makeup water means seawater you cannot give, you have to remove all the salts. Okay, remove all salts, debris, and debris, then you inject into boiler. Because if you are giving water with salt or some other debris, so that will get deposited in the boiler pipes. So later stage will create problem. So whenever the makeup water is getting fed into the boiler, the water must be distilled properly. Okay, whenever boiler is there, so boiler have lots of fittings. So boiler must have pressure gauge because it is pressure. It is pressure vessel. So pressure vessel means if because of certain reason, let's say there is any blockage and you are giving lots of heat and pressure is going shooting up. Okay, so in that case that can be dangerous. So you must have a pressure gauge to sense how much pressure you are developing. Okay, so junction stop valve must be there, feed check valve, how much flow your fluid you are giving, that check valve must be there, blow off cock will be there, manhole and mud hole will be there, so the cleaning operation can be proper. And many other mountings will be there, water level indicator, how much water is there inside boiler, we have to check. Safety valve must be there, preventing excessive pressure buildup if there is too much pressure getting build up. So safety valve will be like, you have pressure cooker, you have seen like household cookings, right? So there will be one extra safety valve. So their boiler also will have some extra safety valve to prevent excessive pressure buildup and bursting. Combined high steam and low water safety valve protects against high steam pressure and low water level in a boiler. Okay. So fusible plug also be there, prevent overheating. So and explosion. Why overheating will be there? Let's say boiler, because of certain reason your sensor not working and overheating started. So this fusible plug will be melted and it will be making safe. And many cases, let's say water level got down and you are giving heat, but there is nothing to take heat from the boiler. So again that will be a problem. So all the systems like sensors, pressure gauge, flow meter, sensors, all the system must be working properly, and you have to observe. Okay, then system will be safe. So whenever you are designing boiler, so boiler you have to consider the cost, longevity, how long it will be running, a running cost. You should not have too much maintenance also. And boiler design may be based on production of maximum quantity of steam, how much steam you are producing with minimum fuel consumption. So performance is very important, economic feasibility of installation, minimum intervention, quick starting, safety regulation, heat source, many other reasons also possible before designing or installing a boiler. Marine boilers, so there will be main propulsion boiler. It's a very big ships, they can have steam turbine system. So it will provide steam to the propulsion systems, and mainly D-type boiler will be there. And auxiliary boiler also may be D-type. D-type water tube boiler like Babcock, Wilcox and other type of boiler also used for marine applications. Waste heat boiler, I already explained that if there is any waste heat from other engines, IC engine, any other engine, so there also you can use boiler, you can heat water, then hot water or steam you can transfer to other places. Okay. So there will be some composite boiler, composite of exhaust gas economizer, oil fired boiler, usually used alongside the diesel machinery. So that's why this is called composite. So you are using exhaust gas. Again, you have another fuel system. Consider for small auxiliary boilers generating steam for auxiliary purposes, cost effective solution for smaller vessels. Superheater. So increase the steam temperature to utilize the heat from a combustion gas, enhance energy transfer. So I already told that saturation steam we are not using for turbine, you have to superheat. Okay, this is superheated zone. Okay, so you have to create this superheat, then you put turbine and you run the system. Okay. Three main superheater type is there. Radiant type superheater located in the furnace. Inside furnace it will be there, directly exposed to the radiant heat, superheats steam to a high temperature. Convection superheater and separately fired superheater. Separately fired superheater, it will be giving very high temperature, but convective superheater, it is little bit lower temperature will be there. So use of superheater. Superheater, it will be giving dry steam, dry, wet, actually high quality steam. When you say high quality, so high quality steam means like I have a vapor envelope, my steam should be outside this envelope, superheated zone. Okay, if something is inside, so quality low. So amount of percent of steam in percent of water, uh, if high, then it is low quality steam, low quality. Okay, so let's say I don't have any water content in steam, let's say purely superheated zone, I am getting the steam, so there is very high quality steam. But if I using steam here, that means some water content also there, because I told inside there will be water content also there, water plus steam mixture. So there will be low quality steam. So our target should be to produce high quality steam, so that will be very much beneficial for turbine. So moisture in steam degrades, corrodes machines, reduces operating life. Converts low quality steam to high quality steam in superheater. and many cases you have to transport steam from one place to another place. So, in that case, instead of forming liquid, you create superheat so that steam will not form liquid or it will not get deposited. Okay. So, only steam you can transfer. Used in a steam engine, dry steam prevents wear and tear. Okay. Steam engine we will discuss later. Lamont force circulation boiler. So, I will draw one boiler. You can see this one. How does it look like a Lamont force circulation boiler? Okay. So, first water will be coming, one pump is here, okay, from drum is here to superheater, from drum some fluid is coming to pump, pump to furnace, wet steam, okay. Wet steam is going like this, it is going like this, again it coming to this drum. Then from drum again you take steam, you pass through this furnace again and you are getting superheated steam. Okay, first you get steam done, then again next level whatever steam you are getting you pass through furnace again, so that will create superheat. So, to get superheat some you have to put the pipe or whatever saturated steam you got inside your furnace again, so that you can get more high quality steam or dry steam or superheated steam. And water will be entering here. Water entering here. So, water will be going like this. Okay, it is going to your drum. Okay, this is economizer. So, okay, inlet water is coming from economizer. Economizer is here. Okay, flue gas will give some heat to feed water. So, that is called economizer. Okay, this is called forced circulation. Forced circulation. Okay, it is written there. Lamont forced circulation boiler. So, whenever I already told that boiler feed water or that makeup water must be uh, cleaned properly. So, when you are cleaning, no salt, no debris, nothing should be there. It will be pure H2O. Okay. So, fouling deposits in the boiler diminishes heat transfer. So, if you have lots of salts or debris, so it will be deposited inside tube. So, finally, this tube will be getting blocked. When it is getting blocked, your fluid flow can be stopped. Another thing is that this metal, the pipe metal or tube metal will have high heat conductivity. Now, you have deposition. So, the deposited material will have low heat conductivity. Okay. So, deposited material will have low thermal conductivity. So, low conductivity will be there. Okay. Again, it will be blocking path. So, whatever extra fluid, extra water you are giving, that must be properly cleaned. The presence of non-volatile salt and minerals in feed water leads to this issue, as they tend to concentrate in the liquid phase, necessitate excessive blowdown or draining to avoid the formation of solid precipitation. Particularly problematic are minerals that result in scale formation. Okay. So, inside pipe there will be scale formation, there will be strong almost metallic thing, but heat transfer rate will be lower, it will be blocking. So, that is a negative thing. Consider the makeup water introduced to compensate of any feed water losses should ideally be demineralized or deionized. Okay. This makeup water. Another term is coming, scaling, that is called fouling. Scaling is that lots of salts will get deposited. like calcium salt, magnesium, silicon, iron, aluminum, if there in the water, then it will be deposited in the heat transfer surface. Okay, it will be very strong salt will be deposited, uh, hindering heat transfer, causing hot spot. Calcium, magnesium salt along with elevated silicon related to water alkalinity are primarily scale contributors. The scale consists of carbonates, bicarbonates and sulfates develop gradually and impedes heat transfer efficiency. Carbonate deposits identified by effectiveness in acid form dense scale with large. Okay, silicon is deposited results in hard light colored scale resistant to hydrochloric acid solubility. Regular maintenance is crucial to avoid all these issues.